Hi everyone, welcome back to my YouTube channel. So today we are going to study chapter 3, design and construction of sewers. So the design criteria are: first determine the quantity of sewage and the storm water, that is Q sewage and Q of storm water. Then the design period is taken as 25 to 30 years. Third step, select the types of the system. For separate system, the sanitary sewage, quantity of the sanitary sewage and the storm water is calculated separately. For the combined system, the sanitary sewage and the storm water is added as fourth step. Select the shape and type of sewer, that will be closed or open water. Then the sewer size will not less than 15 cm, but recommended is 20 cm generally. Commercially available are 15-20 up to the 16 cm, maximum up to 3 meter. Minimum sewer gradient is taken as 1:100 and the maximum gradient is taken as 1:20. Then sewer designed to flow 1/2 to 2/3 full at a peak flow. In the step, sewer having the self-cleansing. So the self-cleansing velocity for a sewer formula for the self-cleansing velocity. Generally, the specific gravity of particle for the organic is taken as 1.2 and the inorganic particle is taken as 2.65. The next topic is hydraulic elements of the circular sewer. After studying all this formula, we will solve almost all the numerical problems in this chapter. So here, hydraulic element, for the hydraulic element of circular sewer, for the sewer running full, when the water is full, and when the circular sewer running half full, circular section running just full, the flow area will be pi d square upon 4, where d is the total diameter of the sewer. Weighted perimeter P is equal to pi d. Now the hydraulic mean radius will be area upon perimeter, that will be d by 4. For the circular section running half full, for this we have flow area is equal to pi d square upon 8. So this with this, and the perimeter will be, flow area will be pi d square upon 8 and the perimeter will be pi d upon 2. The hydraulic mean radius will be d by 4. So both are the same. Now for the circular sewer running partially full, so d for the partially full, d will be the total internal diameter. Therefore this half will be d by 2 and this will be d by 2. D, small d be the depth. Let theta be the this total is the theta, that will be the angle subtended by the weighted perimeter at the center of the sewer. So half will be theta by 2 and theta by 2, that will be divided into two angles. A, small a is the area of the flow section, P is the weighted perimeter, R is the hydraulic mean depth, that will be small a by P, and P is the velocity of the flow. So here the central angle theta is given by the expansion cos. This cos theta by 2 will be equal to 1 minus 2 d by d. So you must remember these formulas. You must remember all these highlighted formula from this chapter. Now the depth of the flow, small d will be equal to this half d by 2 minus this total length, that will be d by 2 minus half of the diameter cos theta by 2. This length will be d by 2 cos theta by 2. So the depth of the perimeter, the depth of the flow will be equal to d by 2 1 minus cos theta by 2. Now the proportional depth is the depth of flow divided by the diameter, which will be equal to 1 by 2 1 minus cos theta by 2. So you guys must remember this and this. Now the area of a flow section. So the area of a flow section, for this you have to remember this, and you guys just can screenshot this, and this all will be the formula that will use in the numerical of this chapter. So proportional area is the area of a flow section by the area of the sewer. So that area of a sewer is pi d square upon 4. So for small a, we can just use this pi d square upon 4 times theta by 360 degree minus sin theta by 2 pi. Now for the hydraulic mean depth, we have R is equal to d by 4 this and this, and for the velocity of flow from the Manning's formula we have v by v is this and this. Q, discharge of the flow by the discharge of the sewer, is this. So this will be all the formula that we will be using the formula. Now we are going to solve one numerical from this chapter. Here the given numerical is to calculate the diameter of a sewer to solve an area of 2.5 square kilometers. So here solution given, we have to calculate the diameter of a sewer. Area is given as 2.5 square kilometer, that will be 2.5 square kilometer, which should be converted into the hectares. So we have 1 square kilometer is equal to 100 hectares. For 2.5 square kilometer we have 250 hectares of area with a population density of 400 persons per hectare. So the total population will be equal to 400 times 400 into 250, that will be 1 2 3 4 5 100,000 populations. Now the sewage rate of water supply is 110 LPCD. So R is equal to 110 LPCD. The coefficient of runoff for 50% area is 0.5 and the remaining area is 0.6. So therefore the total runoff will be C1 A1 plus C2 A2 divided by A1 plus A2, which will be equal to 0.5 into 0.5 plus 0.6 into 0.5 divided by 0.5 plus 0.5, which will be equal to 0.55. Now the time taken to reach by the storm water at the considered point of the sewer from the farthest point is 17 minutes. So the time of concentration is given as 17 minutes. Now consider the storm duration 21 minutes. Value of Manning is n is equal to 0.013 for all depth flow. The permissible slope is S is equal to 1 by 500. Also the peak factor is equal to 2.7 and the sewer should run half, that is this, the sewer should run half. So d by d will be equal to 0.5. Now here assume 80%, we assume 80% of water supplied is converted into the sewage. Discharge. So first we will calculate the total quantity of the discharge, the total quantity of the sewage discharge. For the quantity of a storm water will be equal to CIA by 360. So here the runoff coefficient is the runoff coefficient we calculate is 0.55. So here C will be 0.55 into the intensity I will be is equal to of rainfall will be 1020 by T plus 20, which will be equal to 1020 by 17 plus 20, which will be equal to that is 27.56 mm per hour. So here 27.56 into the total area we calculated is 50 hectares, 250 hectares divided by 360, which will be equal to 0.55 into 27.56 to 250 by 360, that is 10.53 cubic meter per second. Now the quantity of the sewage will be equal to 80% of water supplied is converted, 80% of rate of water supply, that will be 0.8 into 110 LPCD will be converted into cubic meter per second, that will be 24 into 3600 into 1000 times peak factor is 2.7 and the total population is 100,000. 75 cubic meter per second. Now the combined quantity of the sewage will be equal to quantity of storm water plus the quantity of the sanitary sewage, which is equal to 10.805 cubic meter per second. Now we have already calculated the discharge. From the Mannings we have discharge equal to 1 by n, a r to the power 2 by 3 and s to the power 1 by 2. Let this be the equation first. Also we have the formula a is equal to pi d square upon 4 bracket theta by 360 degree minus sin theta by 2 pi, that will be 0.393 d square in terms of depth of it. Now we will calculate the hydraulic mean depth is 0.25 d in terms of the depth. From equation first we have the value of Q is 10.805, which will be equal to 1 by n is equal to 0.013 times A is 0.393 d square into R 0.25 d power 2 by 3 into slope is 1 by 500. So solving this we get the value of depth, that will be 10.805 equal to 1 by 0.013 into 0.393 x square into 0.25 x power 2 by 3 into root under 1 by 500. Solving we get the value of d as 3.083 meter. So the required value of the diameter of seaware will be 3.083 meter. This will be the answer.